Now we go to the fourth characteristic, that is related to change in energy. So, when we talk about any chemical reaction, there is either some energy absorption or there is some release of energy or evolution of energy. So, based on that, we categorize chemical reactions as exothermic reactions and endothermic reactions. About this, we'll be discussing in types of reactions more. So, exothermic reactions, in these chemical reactions, heat energy is released or evolved. So, we are talking about the net heat energy released or absorbed or evolved. So, in endothermic reaction, endo means absorption, exo means release. So, we can remember with these terminologies. So, in these chemical reactions, heat energy is absorbed. So, now we'll take the examples. So, the very basic reaction for exothermic reaction where heat energy is released, we can take combustion reaction. Carbon is in the solid form, it can be coal, it can be charcoal, it can be any form of carbon. So, it's burnt in the presence of oxygen to give us carbon dioxide, and heat energy is released. And in this case, since we are taking carbon or coal over here, so even light is also released. So usually when we are writing exothermic reaction, we will prefer writing heat plus heat, added heat, like it's getting released over here on the right hand side. Or we can write like this also, minus heat. This is also indicating that these two are exothermic reactions. So either you write heat released on the product side, or you can write minus heat on the left hand side of the chemical equation. Another example we can take for exothermic reaction, calcium oxide. CaO is a formula, and commonly we even call it as quicklime, or simply we call it as lime. So when we add it in water, this is in the solid form. So when we add it in the water at room temperature, so usually we do this process in a china dish. So once they chemically react at room temperature, they will form calcium hydroxide, which is slake lime. We even call it as lime water. So the chemical name or the standard name is calcium hydroxide. So either we can address it as lime water, slake lime. So just like calcium oxide has quicklime and simply lime as a common name, so we need to remember it. Again, heat energy is released. So it's a perfectly balanced equation, just like the previous equation was. Then we can take one example of endothermic reaction. So calcium carbonate, it's a salt. We even call it as commonly limestone. We even call it as marble, or commonly people even call it as chalk because it's one of the major component of chalk. So if we burn it, endothermic reaction. Most of the endothermic reactions usually have one reactant, but we can't just make a statement like that because there can be many exceptions where heat energy is required for two reactants to react to give you a single product or multiple products. So, definitely in this case, we are providing heat energy. So, either you can write a triangular form above the arrow, or you can write like this, plus heat. So, when calcium carbonate is going to be decomposed, or when we are going to heat it in a test tube, so it has to be raw. It cannot be in the aqueous form, it has to be in the solid form. So, when it decomposes, it actually changes into calcium oxide and carbon dioxide. So, calcium oxide, I already told you the common names. Carbon dioxide is a colorless gas. So, this reaction holds an important aspect because this is a commercial method of production for lime and even carbon dioxide. So, industrially, if we require carbon dioxide for any industrial process, any commercial process, be it your carbon dioxide, be it this calcium oxide, so we will use this particular equation industrially because it's way cheaper and it's not that difficult to obtain. So, we can even write plus heat like this. So this is in the solid form, this is in the gaseous form, or you can write minus heat on the right hand side also. That's up to you. Then if we go to the next one, the fifth characteristic in depth, that is change in physical state. So we can categorize this equation before moving to that last characteristic. We can actually call this particular reaction as a combustion reaction. Combustion reaction is burning in the presence of oxygen. It can be called as oxidation reaction also. Definitely, we can call it as redox reaction. We can even call it as combination reaction. And then we already categorized it as exothermic reaction. So one reaction can come under so many categories. It can be combustion, redox, combination, then exothermic reaction. Similarly, now this is also a type of combination reaction. I'll explain combination reaction in a couple of minutes. So combination is when you combine two or more reactants to give you a single product. In the above case also, we are getting a single product, that is only carbon dioxide. In this also, we are getting only one product, calcium hydroxide. So it's a combination reaction, it's a redox reaction, and it's an exothermic reaction. So we have redox, so we have categorized it. Then we go to this reaction. This is definitely your this is redox reaction. It's an endothermic reaction. Decomposition, to be more precise, we even call it as thermal decomposition reaction. So many ways we can categorize a particular reaction. So change in physical state. So from the term itself, physical state can be different from the reactant and the product side. So we can take this example where hydrogen gas is reacting with oxygen gas in the presence of electric current or electric spark, and this reaction is happening at room temperature. So we are getting water in the liquid form. So we have to balance this. The above equations are perfectly balanced, so no need to add any stoichiometric coefficient. So in this case, I've already balanced water, so we can have balanced hydrogen also over here. So water is in the liquid form, whereas these two are gases. So we will get water as a product. It's a very important reaction. So it's a mixture of hydrogen and oxygen. So we are going to ignite with an electric spark at room temperature, and definitely we are going to get water out of it. Now, the next reaction that we're going to take over here under the change in physical state is reaction of ammonia and HCl. Now, ammonia is in the gaseous form, HCl is in the gaseous form, so we are not taking HCl as hydrochloric acid. So, HCl gas diffused in water is hydrochloric acid. It's an aqueous form of you can say HCl gas. So, when they chemically combine, so we will get ammonium chloride, which is solid in state. Again, it's a perfectly balanced equation. So, this ammonium chloride is a white powder. So it generally is formed in the form of fumes, but after some time we can actually cool it down to some solid powder. So ammonium chloride, it's a salt. So ammonium chloride is formed. There's a very, you can say, good question we can make out of it. So let's say we have a tube. So now this is multiple concepts we are going to mix over here in this question. So let's say on the left hand side we added ammonia gas. We diffused it. We just released ammonia gas from left hand side end, and from the right hand side end we added HCl. So we are taking only 1 mole of each. So now the question is, so let's write the question, where ammonium chloride will be formed. Will it be near the end where ammonia was released, or the end from where HCl gas was released? So now in this case, we need to understand a concept of rate of diffusion. Rate of diffusion of gases. So this was given by a very famous scientist, Graham's law of diffusion we call. So he said the rate of diffusion of any gas is inversely proportional to under root of its molecular mass. So it can be inversely proportional to under root of its density, because mass and density are directly proportional to each other. Density is equal to mass per unit volume. So from here we can see that density is directly proportional to mass, and it's inversely proportional to volume. So point over here is that I'm not going in depth when it comes to Graham's law of diffusion, but this is a very important question, that if there are two gases, so it is very much dependent upon its mass, which is going to be diffusing faster. So now if we know this, so what this particular relationship is going to indicate? So it's going to indicate heavier gases diffuse slower compared to lighter gases. So we have to go back to our basics which we discussed. So we can just calculate the molecular mass of ammonia. So ammonia, nitrogen mass is 14. So we can calculate gram molecular mass 14, and hydrogen is 1 into 3. So this will be 17 grams. HCl, hydrogen mass is 1 and chlorine is 35.5. So this will be 36.5. So definitely HCl mass for 1 mole is heavier compared to ammonia. So where ammonium chloride formation will happen, where we will see the dense white fumes. So you can even write this, dense white fumes, where we are going to observe whether it's going to be near to HCl or it's going to be near to ammonia. So you can pause over here and think over it. So The answer over here is going to be near to HCl, somewhere near to HCl. Why is that? Because ammonia is being lighter comparatively to HCl. HCl being heavier won't be able to diffuse faster, but ammonia being lighter can diffuse faster. So definitely it will pass more area. Like this is very much, you can say, we are not talking about from the mathematical point of view, but we are talking in general. So ammonia will be able to diffuse faster. So definitely it will move quickly towards the, you can say, toward the near, or you can say near to the end of this HCl. So HCl will not be able to move, you can say, faster. So you can say the dense white fumes are never going to form in the middle because ammonia being lighter will diffuse faster. So the time period that HCl is not going to cover much because it's heavier, but ammonia will diffuse faster. So we say that it's nearby towards the end where HCl has been diffused because HCl have been diffused because it's quite heavier and ammonia being lighter. So this is how chemistry works. You have to mix so many concepts to make one question, and in the future it will happen more aggressively, so we need to keep multiple things in mind. So but eventually everybody learns, nothing is difficult in this life. So moving ahead, next topic that we are going to discuss is types of chemical reactions.